Welcome to qnawire.
Okay, so this is the force diagram for the crate. Let's apply force equilibrium. So therefore, the net force along xy direction is equal to 0. So we have the net force along x direction is equal to friction minus the force P, which will give us the friction on the crate is equal to the force P applied by the man. And then on the y direction, we'll have a normal force minus the gravity of the crate and is equal to 0. And this will give us normal force is equal to gravity. So we know the friction in this case can be equal to mu Sn. Mu s here is the coefficient of the static friction between the crate and the floor. And this can be equal to mu Sn, which is equal to mu Sw, since n equal to W. So we know mu s is 0.3, and the gravity of the crate is 450 pounds. And this will give us the friction on the crate is equal to 135 pounds, which means that force P is also equal to 135 pounds. So now let's assume that the crate tips about 0.0 here. Therefore, we can apply a moment equation about 0.0. Consider counterclockwise moment is positive, clockwise moment is negative. And this will give us P times 3 feet minus W times 1 feet is equal to 0. And this will give us P times 3 feet is equal to W times 1 feet. As you can tell, unit feet can be cancelled out, and this will give us 3P is equal to W. So eventually have P in this case is equal to 150 pounds. As you can tell, 135 pounds is less than 150 pounds. Therefore, the smallest value for force P should be equal to 135 pounds. So in order to move the crates, the minimum amount of force that can be applied should be equal to 135 pounds. So now let's take a look at the force diagram for the person. So now let's apply the force equilibrium for this case. So the net force along xy direction is equal to 0. So have P minus Fm is equal to 0 along the x direction. So have P is equal to Fm. Fm here is the friction on the main. And on the y direction, we have Nm minus Wm is equal to 0. So we have Nm is equal to Wm. Nm here is the normal force on the man, and Wm here is the gravity of the person. And we know friction can be equal to mu s prime times Nm, which is equal to mu s prime times Wm, since Nm equal to Wm. And mu s prime here is the coefficient of the static friction between the person's shoes and the floor. And we know mu s prime is given as 0.6, and the person's weight is 200 pounds. So eventually you have the friction is equal to 0.6 times 200 pounds, which is equal to 120 pounds. And this will give us force P is equal to 120 pounds. As you can tell, the force P here is less than the minimum value for the force P that should apply to move the crates. Therefore, we also know that the force P here is less than the friction on the crates, which means that the person cannot move the crate since it's less than the friction. Okay? And this is the answer for this question.